We talked about this yesterday. We talked about that yesterday, but those are due. Hey, you're not judging. You're not helping when you're judging. I had extra pens, but I don't know where my normal pens went.
You had a sign that says look in.
I know. Oh, here's one, but I'm still missing one. What? Where? Aha! What's that? Good work, but now we gotta do better moving forward. Alright, so we today are going to, on your graph paper that you should have out, remind ourselves how we solve these problems, and then we're going to look at your homework sheet, and just like DJ Hudcap will take your requests, Mr. Hudson does the same, but for math. So I will solve problems by request. So yes, the entire homework sheet, it's bigger than normal, but that's the last homework I'm giving you through like Turkey Bowl, through next week, through like, this is it. So this sheet these homework problems should inform you of whether or not you're ready for the mini mastery. The other thing we'll do today is show you the mini mastery. So when you walk out of here, you'll know what you need to show mastery on tomorrow. Okay? Hey, 5 people in the back. Normally that's only 4. It's okay to be 5 today if you can handle it. Okay? You guys got to be able to handle it. Do you have the cherry sheet and everything else, right? Okay, sweet. Graph paper. Everyone have graph paper out? Guys, I got a lot of extra cherry sheets up here, like too many extra. Don't edit that. You can head your paper, or not even the header, but like the label for today's class. Maybe this is just so many people are sick. Are we sure everybody has the cherry paper?
Yep.
Now what's going to be weird is next year I will be reusing these, and I either have to match the color, or some people will have cherry sheets and some people will have other. Which this chapter now has been a variety of colors. PropRel, what's PropRel stand for? Proportional relationship. And what, this is on the mini mastery tomorrow, what is, probably not, we won't do a C. What is a proportional relationship? Ooh. Morgan? Yeah, we're one value. Yeah. She said, if you couldn't hear Morgan, she said, like, where one value is like 3 times the other one. Excuse me, it's any situation where one value is a multiple of the other. So like when you go pump gas, or when I go buy apples, or like anything that doesn't have a bulk discount, right? So we looked at potty pads. I forget if we did it in both classes, but I pulled up Amazon, because I have a sick dog at home, and we looked at potty pads, and we saw there's a discount as you go up in quantity. That's not a proportional relationship. But if I go to the store and I buy one pizza, and another pizza, and another pizza, like that's going to be a proportional relationship. We start to talk about these proportional relationships in a y equals k. I don't like that they're using fine. Y equals kx. The other way that we talk about this is y equals mx. So actually go and write down both of these. like literally probably stacked on top of each other, so you can see that the K and the M are the same thing. You know, R is just P taking a step.
I know, right?
Think about it. P, when he goes to take a step.
What? Oh!
Sorry, I saw that on Reddit. It took too long to appreciate that. That's funny. Yes, I'm a 30-year-old in the year 2019 and don't have Reddit. Yes, of course I'm on Reddit. Well, thanks.
What's your Reddit account?
Ha! No.
What's your highest
You know what Reddit pages I'm on? r/education. r/math teacher. Not joking. The two pages I most visit. r/camping, r/disco. Right? It's a forum website. So, K is more of a newer way that we talk about the constant of proportionality, and they started using K because constant. M is what we'll see a lot of places, and if you start asking your parents or older siblings for help, they'll probably talk about y equals mx. Whether we talk about M or K, please label it on your paper that is the constant. Sorry, it's spelled with a C. That's the constant of proportionality. You cannot just write constant, because that's wrong. A constant is a number that's not multiplied by anything. So that's the constant of proportionality. And I will probably not ask you to write that word again, because it's really big. There's a Y that barely fits over there. Let's see if I can drag this word over. Okay, we're no longer spending class time talking about the internet. This is not a class about the internet. Right. So, Graham. Hey, remember that whole thing on the start slide that said we'll work on the problems today? That's only a commitment if we get through what we need to get through. So it's up to you. But I'm hot because there's hot lava pouring on the vents. So sorry if somebody gets cold, let me know. But Graham works for. Does it tell us? Okay, so Graham works for a relative, right? A neighbor, somebody that, because he doesn't always work a whole hour, because he doesn't always work a whole hour, go ahead and write that down. He makes $4.23 for every half hour. Yes, this neighbor is senile. They are like, why would you $4.23? Like, they've got a lot of change to get rid of. Let's just say they enjoy getting rid of the change. Max, I might need to cut that down so you're able to write things down. Because right now, both your hands are committed to that. Do you need a Clorox wipe or anything? I can give you a wipe to wipe your hands. You good, or are you ready to write this down? Okay. So now, I want you on your paper, figure out what he would make in 1 hour. Or 2 hours. Or, let's say, he works like a full work day. What about 8 hours? A full work day is normally 8 hours. We're here for longer, actually. So hey, if we go to use a table, let's set up a T-chart. On your paper, you're going to have time and money. What's the first thing we fill in here? Yeah, 1/2 of an hour and 4.23. So, and I'm going to put like HR over here so I know that's hours. So 1/2 makes him 4.23. Ooh, I know how we could use random cards. We'll go back and forth between which class. So, it would only be appropriate to start with 1A. Yeah. Toby. Oh, God. What? I love it. Yeah, start with 1A. Aw. Toby, if I make 4.23 in a half hour, how can I figure out what I make in 1 hour?
Well, you can take 4.23 and multiply it by 2 to get 1 hour.
Ah, because to go from here to there is at times 2. So we do the same thing over here. Guys, drawing those arrows is really helpful for your brain. It like allows your brain to see the connection between the left and the right side, that the same thing is happening. So it would help you if you draw those arrows and put those times 2s. This isn't that hard to double. Nothing carries over. If I double 4, it's 8. If I double 23, it's 46. That's actually a reasonable pay, right? 846.
Isn't that below average?
I don't know what minimum wage is right now, but probably this textbook's a couple years old. Like it's like 3 or 4 years old. So that was probably minimum wage, like close to minimum wage back then. So then, hold on. Let's do something. Let's go to 8. Let's just jump right to 8. Oh, who said it? Times 8, right? Because from 1 to 8 is times 8. So times 8. So yeah, now we probably want to use a calculator. Maribel? You sure? 846 times 8? I think you did the 423 times 8. If we are coming from 1, if we're coming from 1, it's times 8. Hold on, be careful. Look up here. If we're coming from 1 to 8, it's times 8. But if you were going from 1/2, you'd have to do times 16. So be careful. Okay, my calculator people, what is it? $67.68. Okay, so that's pretty good. He works a day, but let's say it's summer break. And not only can he work full work days, but he can work a full work week. How many hours are in a full work week for normal people? 40. A normal work week is 40 hours. I do, but you don't have to. How do you go from 8 to 40? Times 5, right? This is times 5. So this is times 5. What is it?
338.
So guys, you might at first look at 846 for every hour and say, that's not that much. But if you actually worked a full day and a full week, you come out with $338.40.
People don't like
Dude, you could make that. So, hey, side selfish note. For your older siblings who might be 16 or older, Lifetime, where I work on the rock wall, is trying to hire lifeguards, and it's an easy, fun job. You have to get trained, and it costs money to get trained, but then you sit in a chair or walk on a pool deck and tell people to stop running. And occasionally jump in and pull out a kid who can't swim and should have known that. So tell your older siblings, or when you turn 16, because it's a first aid job, you gotta be 16. Come get a job. You pay $12 an hour. Not 8. It's a lifeguard job. Lydia? Seriously, I posted on the PTSA Facebook page. Like, I posted the job. Yeah. And say, you can go. You can go.
I feel like
Yeah.
every time they go to the whole world, I hate
Do what? You have to go to the jet. Like, if your parents drop you off or
This is like me.
why is this
Yeah,
showing a bad
don't
driver?
die.
I have 2 questions.
This
Yeah.
is like these kids. I'm not here now.
Eric.
How much
Very loud.
would
Not
it
yelling
cost
and
you to train?
It's like $200. You have to be 16.
And also,
So, hey, look, so
It's 240.
if your reaction to that was just fun, because if you pay $225, $240, whatever dollars to get trained, but then you work a week, and we pay more than this, right? So if you worked a week, you pay back your training. So that's why it's worth it to get the training.
and also, how old do you have to be? Since I asked a lot of people this and they give me 6 answers. How old do you have to be to do carts at grocery stores?
No idea.
It's 14.
Yeah, go ask Kroger. Hey, let's compare this.
Male Kroger. Do we find it in how much that makes annually?
Draw like a divider, squiggly line or something. Well, then make another table somewhere else. Real quick, because the math is easier. If you go home and tell your sibling, hey, go be a lifeguard, they pay $12 an hour. Let's play this out. 1 day, 8 hours. To go from 1 to 8, times by 8. So 12 times 8, 96. So look at the difference in 1 day. $67, $96. Full work day. Then, full work week, we said from 8 to 40 is a multiplication of 5. So this multiplies by 5.
96 times 5.
I got 480.
Guys, look at the difference. So, no, like I was a lifeguard in high school because it pays better. You could go work at a grocery store and get minimum wage, right? Or if you get some training, right, put some effort in, you gotta have some grit, you can make more money. And this is really the end goal with everything is become an expert on a thing and then get paid for it.
Are you getting paid a lot?
Right?
Can I ask you this earlier? How long does it take?
If you want information on the training class, go look it up. I am not the expert. I work at the Rockwell. I don't do anything with we just need to hire lifeguards. Whenever I need to. Alright, so now we're going to start, sorry, no more questions about that. We're going to start having quantities that aren't full. They aren't halves. Go ahead and write that down. 9.3 miles in 1.5 hours. Now, some runners run, I'm going to go out and run a specific length. Some runners have a certain amount of time they're going to run for. So let's say you go to the gym or the wellness room, and you get on a treadmill and you say, I'm going to run for an hour and a half, and you just watch TV, right? You don't pay attention to how fast you're running, because at gyms that you go pay for, there's TVs there, because adults are I want to work out, but I want to watch the news, or whatever. So you watch TV, you get done with your run, and you're like, oh, I ran 9.3 miles in an hour and a half. I wonder what my speed was. How do we measure speed in America? Lila?
Well, one of this is extreme. I'm pretty sure you have to divide you have to divide the number of miles ran by the number of hours.
Yeah. Speed is talked about in miles per hour. Kayla? Hey, you're having a full-on conversation while I'm trying to teach. That's really rude. Not only is it my job to teach you math, but socially, come on. I feel very disrespected here. Okay, so it's both of you, but if I can help you with something, let me help you. Otherwise, this is a problem you're going to face on a mastery, and I want you to know how to do it. So it was easier when we started with the half hour because we were able to just double it and get a whole hour. Right? So when we started with the half, that was easier. But when we start with 1.5, let's just go ahead and set up 9.3 miles over 1.5 hours. We're going to build a proportion to solve this. Everybody should have that in the empty fraction bar. Now, Maxton said we could find 3 hours. How would you do that? Multiply by 2.
Yeah.
And that math isn't bad, right? 9 times 2 and 3 times 2. 18.6. Now what could we do? Yeah. Divide by 3. What's 18 divided by 3?
6.
What's 6 divided by 3?
3.
Ooh, careful.
Oh,
2. Yeah, don't fall in that trap.
I found it.
So that's 6.2 miles per hour. Maxton found the easy way that didn't need a calculator. Right? We don't need a calculator for that. Now hold up, can anyone tell me how we could go from 1.5 straight to 1? How can you turn 1.5 into 1? Logan? Anytime you have any number, guys, give me your eyes. This is like the secret passageway straight to the finish line.
Okay.
Seriously, like if you've ever played Mario Kart, like this is the secret passage straight to the finish line. Take the number in the denominator, and that's what we divide by. So up here, if you have a calculator, do 9.3 divided by 1.5, and you will get 6.2. That's the secret passage to the finish. You just take whatever the denominator was, we're going to divide by that. So guys, essentially you just do this division. That gets us to, wait, what was this called? If it's for 1, if it's per 1? No, what is it if it has 1 on the bottom? It's a something rate. Say it louder. Unit rate. You should write that down since like one of you were able to tell me. When we have 1 on the bottom, it's the unit rate. It was broken. That was my, come on, man. On your mini mastery tomorrow, there's a question almost identical to this.
Yes.
Yeah, I also advertise straight up on the PTSA Facebook page saying, please come work at Lifetime. I got no shame. Ever heard of, yeah, shameless plug. That's literally what it's called. Yes, trust me, they're a very large company. All right, so go ahead and write this down. Mixed number. Who here's made cookies before? Yeah. All right, now who here's good at making cookies? Who here has ever burned cookies? Yeah. Funny thing about a timer, if you walk outside, the timer doesn't work as well. Now wait, hold on. Wait, crap. This cookbook is weird. This cookbook just gave us, you should be writing this down and hopefully you noticed this, 2 2/3 cups of flour. Oh, for 2 batches of cookies. Well, that's not as convenient to work with. So, hold on. Let's write that down. 2 2/3 for 2 batches. So we're going to say cups, batch. How can we, Nick, how do we turn 2 into 1?
I had it in my mind, and then I
Keegan? Divide by 2, right? So draw this. We draw divide by 2. Now the last thing I need to teach you today. So I need you, if you're only paying half attention, I need you to come back 100%. Once we have our unit rate, I should have eyes up here once you're done writing. This unit rate is what gets plugged into our equation. So actually, I'm going to make 1 1/3. You guys know I don't like mixed numbers very much. What would 1 1/3 be in the way I like it better? 4/3, right? This is really 4/3. So y equals 4/3 x. Hey, Master, I need you to throw that away, please. Thank you very much. So this actually means the flour we need is 4/3 times the number of batches. Now on the mini mastery tomorrow, I'm not going to be looking for mastery of using the equation, but this makes your life super easy. You want to make a dozen batches, you just plug in a dozen, do the multiplication. You want to make 1,000 batches, you're opening a business, just plug it in, right? Like anything you want, you can plug in here and do the multiplication. Also, check this out. Give me your eyes, put your pencil down for a minute. What if I don't know how many batches? Now for my bakers in here, you'll immediately get nervous because this gets dangerous. Let's say I measure out the flour in my kitchen. And I'm like, you know what? Forget it. I'm in a bad mood. I'm going to bake all day. Like anyone ever just like, I just want to bake.
Yeah.
Cakes, cookies, whole thing. Gonna eat them all. Get some ice cream. Perfect. So you, hold on. Last problem we're doing, then you're going to work on your cherry sheets and get ahead on your homework. You look in your cupboard. You find out that you have, gonna drop stuff, 20 cups of flour. Yeah, you got, like, you measure out, you got 20 cups of flour. What, 3 bags probably maybe? So, check it. Put your pencil down, eyes up here. Here's the other way this equation works. Batches isn't the only thing I can plug in. I can plug in flour. So if I make this 20, just watch. I'm not asking you to do this. I'm just asking you to watch. We're just going to go ahead and change that to B to make it a better variable. We talked about, hey, don't need to master this after Thanksgiving. I just want to show you it right now. To turn a fraction into 1, we multiply by its reciprocal, right? So then if we do that over here, the easier way to do that is put this over 1. This cancels out my 3 on bottom and my 3 on top, my 4 on bottom, my 4 on top. My right side becomes just B. My left side becomes 60 over 4, which is actually, what's 60 divided by 4?
I don't know. 60 divided by 4 is
Close.
12.
15. So what that tells me is if I have 20 cups of flour, I'm able to make 15 batches. But if you're prepping for Phoenix Fair or some big event, maybe you're like, how many batches am I able to make? So there you go. That's how the equation works both ways. Questions?
That's a very bad idea.
What, make 15 batches? Probably at the same time. What, can you use all your flour? Hey, okay, so let's talk about ratios for a second. You can start your cherry sheet, but let's talk for a second. Lily's saying this is a bad idea. Who's ever been in the middle of a recipe and your parents like, add a little bit more flour, or we need a little bit more of this. Like you thought you had what you needed, but then, so you never really want to use up every bit of what you have. So maybe instead of making 15 batches, we make 14 and we keep a little bit of flour. Or we make 10 and we know we have a decent amount of flour in it, right? Like, but this is how you math. I got a lot of people who have chosen to just sink into their chair instead of start working on their homework. Are there any questions up there that automatically make you nervous? Keegan? 61. Sir, we have a request for 61. We're going to do that first, and then we'll go from there. Actually, I think there's 10, but you'll be okay. Yes. I did, thank you. All right, 61. Gravity works.
Don't say it.
This might help you with a lot of problems. Hang on just a second. You can ask for this.
No. It's in ours it says instead of 3 fourths, it's 34.
So first thing, fix that, because we got a format issue. So everybody look at 61. Now, did I catch the 5.85? Is that right? Or does it say 585? So make sure this is 5.85 and 3/4 of a minute. Thank you, Keegan, for asking for this question, because it helped us catch a typo. Speed. We just talked about it as miles per hour, but if we expand larger than just America, right? If we think globally, miles, meters, inches, feet, like what are those things? Of what?
Lane. Metric system. Lane.
Give me another word. Give me a synonym. Starts with yeah, distance. Speed is always. The people chatting are going to be the ones to come ask me about this. Speed is always distance over hours, minutes, seconds, time, right? So when we get asked how fast, we know automatically how fast once distance over time. So now we come down and we say, well, our distance, that's a highlighter, is 5.83. Put your labels in the math, please, because then you are more likely to remember them in your answer. Oh, thank you, Lexi. Too many numbers in my head at once. Thank you, thank you, thank you. Oh, man. Mr. Hudson made this one hard. Why is this not as easy as the ones that we were just doing? Max?
You have to get 3/4 into a 1 second, but you could also turn.
Now wait, hold on. Do we have to? Are you gonna go there first, or what should we do first?
Make it into a another number that's easy, which is 4 times 4, and that's times 3, and then you get 12, and that's 3.
Ooh, hold on just a second.
Hold on, I think I messed that up.
Centimeters. Right? It wants centimeters. We're good. 5.85. Hey, if you've moved on from this problem, that's okay, but we're doing this one together, so please stay quiet. But seconds. Go ahead. Lily, you're dancing around like you got a suggestion.
You have to change the minutes into seconds.
Oh, this has to change it. How do we do that? Math. I agree. What about a 60? Whoa. There are 60 seconds in a minute. I need everyone to come back to us for a second, because this is where I know your errors are going to lie. 3/4 of a minute. If I make a little side box and say, how do I do this? Because I got a lot of people asking. Lexi?
I know the answer.
It's about the process. Nick, do you know the process?
No, I know the process.
Bella?
So there's 3/4 of a minute, there's 60 seconds in a minute. So divide that by 4 and you get 15. So 15 times 3 is 5.
So, I 100% agree with what you did, but I'm going to show the conversion factor. Bella said, take a minute, divide it into 4 pieces, and we want 3 of them. Right? The conversion factor here, because, guys, one thing I wanted to remind you is we can put that label on top. We can just say it lives on top. It is either out beside it, and actually I should probably write this a little bit different. That is not 3 divided by 4 minutes. That's 3 minutes divided by 4. So the label can either be out to the side or on top. It's not on bottom here. That's a different number. So it's either 3/4 of a minute or 3 minutes divided by 4. Our conversion factor, though, we're running out of time, is 60 seconds in 1 minute. So this is actually 180 divided by 4, which probably what Bella's like in her head yelling at me is how many seconds is that actually? Think about a clock. Look at it if you need to. How many seconds is 1/4 of the clock? 15. What's 15 times 3? 45. We are just getting into like where you'll need to master converting units, but this is good to have written down as a reminder of how we do it. You start with 1 with a label in it. We use a conversion factor to get rid of that label, right? These minutes and these minutes, and we're left with the label we want. We got like 5 minutes left. We got another request from this homework sheet. Yeah, Sarah? So that was in your book. That was from another homework that we did. Our proportions web, there's a reminder of it back here. Now, I'm not as concerned about you making the web as just showing these pieces. So you don't have to draw it like a web. It's just asking you, can we define a rule? Can we talk about the situation? Could we graph it? And what did we say about a graph of a proportional relationship? Every proportional relationship graph. This is not on your paper. It's, what, 60 asks for a web? Yeah. Zach, what do we know about every proportional relationship graph? And starts at the origin and it's a straight line. So every proportional graph will look similar. Starts at the origin, has a straight line. Nick?
So then, I remember like a bit back, we tried to stack politics and make like the graph look straight by
What do we use?
changing the numbers.
What do we use to break the graph? Do you remember the symbol? How we broke it? Yeah, it's like a lightning bolt. It breaks the graph, right? It compresses the graph down on itself. So yeah, you're absolutely right. That does happen. Skews our graphs.
But then, would that make it, like, would that still be considered, like, proportional, I guess?
No. Yeah, it has to start at the actual origin, not just, like, look like it. You know what I mean? You can't just, like, break the graph and then say, oh, it's proportional. Look, it looks like that. It has to actually have the 0, 0 point. So we wrote down, like, 0 apples is $0. But if I have a gym membership and I go 0 times, am I still paying for my membership?
Yeah.
Yeah, so that's not proportional. Other requests? Morgan? Sorry, I can't hear you. 52. Going back in time. The time traveling. This is from last night. Ooh, thank you so much. Mr. Kabila will appreciate that we're going to talk about this. Yeah, because this is science. Yeah, science. I like when you guys match the speed. Okay, I have 3 minutes, and this is not an easy problem. You should give me your focus. Unless you're totally done with last night's homework, then okay. In science, we often end up having to convert temperatures because America did the thing we did, and we were, digging in our heels. We're going to keep our system. So, if Paige normally bakes her bread at 350 degrees in an American oven, and she's in Australia right now, where they measure in Celsius like most of the world, we've got to convert. So, okay, bring it back. Just like 3 feet in 1 yard, there's a certain amount of Celsius and Fahrenheit conversion, but it's not easy. Look at this mess. So we use the formula to do it because it's not just a direct multiplication. It's not just a direct division. There's a subtraction and a multiplication. So what we do is we set up C equals, we have Fahrenheit. So we, what's that S word where we plug something in? Like the teachers that fill in when we're gone. We substitute. So 350. Guys, you know this homework's due tomorrow, right? So if you don't have this problem done and you're packing up, that's the wrong choice right now.
Oh, that one.
Yeah, this problem's on last night's homework. It's due tomorrow.
That's what we're talking about the people.
And now we just use a calculator. Look at that. Calculator. Calculator.
Calculator.
So, Lily, if we follow the order of operations right, we should get something that is a lower temperature. So do the numerator and then divide by 9. Who's got this temp?
Oh, I got it.
Olivia? That seems too low.
I got 176.6.
That's probably what it is. I gotta get you guys out of here. You get it? Whoa. Yo! If you got 17 here, you did the order of operations wrong. You need to do the numerator and then divide by 9. Minus 32 times 5. Then divide by 9. It's 176.6 repeated. Alright, get out of here. You're going across the way. You're going across the way to social studies. What?